Hello everyone, welcome to my talk. I'm Limbo Mo from the Ohio State University. Today I'm gonna talk about our paper titled by Inspired, a large-scale dataset and a simulation framework for exploring interactive learning in knowledge-based question answering. This is a joint work with Ashley Lewis, Huan Sun, and Michael White. In this paper, we focus on the task of semantic parsing, which is to map natural language to formal meaning representations. Here is an example of semantic parsing on KBQA. We have a question from complex web questions dataset. Semantic parsers can translate it into a logical form like SPARQL query, which can be directly executed on knowledge base to retrieve answers. However, semantic parsers face challenges. First, the accuracy is not high enough for real use. Second, it is hard for users to understand the parsing process and allow them to validate the results. So we would like to have an approach that aims to create a correction strategy when the parse is wrong. And here's where interactive semantic parsing comes in. It is essentially incorporating human users in the loop to resolve utterance ambiguity, boost system accuracy, and improve user confidence via human-machine collaboration. In this paper, our goals are as follows. Basically, to enhance the transparency of the parsing process, increase user confidence in the final answer. Last, to improve the accessibility to knowledge bases. Here's a dialogue example of what we would like to achieve. We aim at designing an interactive framework that demonstrates the question answering process in a step-by-step fashion and allows the user to make corrections to individual steps in natural language. So just to give a quick look at what we did in this work, we propose an interactive semantic parsing framework instantiated by KBQA. We construct a high-quality dialogue dataset and also establish baselines for 2 subtasks under our framework and develop a simulation pipeline to study the promise of our framework to correct errors from other semantic parsers. Here's an overview of our framework. So given a question, we have an initial parser to map it into a logical form. Then, we have a logical form decomposition module to decompose the initial parse into sublogical forms. After that, sub-question generation module is used to translate each sublogical form into a natural language question for human to understand. Then, human provides feedback in natural language to correct each step. Finally, the parse correction module incorporates human feedback to generate new sublogical forms to make correction. Okay, then to implement such a framework, we construct a new dataset called Inspired via crowdsourcing. It is sorted by interactive semantic parsing for correction with decomposition. This dataset consists of over 10,000 structured dialogues. This table shows various statistics of the Inspired dataset. Feel free to check our paper for more details. In our experiments, we have 3 major parts: parse correction with natural language feedback, sub-question generation, and dialogue simulation. Okay, let's start with the first subtask under our framework, that is parse correction. Basically, it converts a sub-question to a new sublogical form for correction. We establish a bunch of baselines and further explore the effect of different contexts. Here are some results shown in the table. As we can see, incorporating human feedback can substantially improve the parse accuracy. Also, adding context into the input constantly improves the correction accuracy. Then, as the second subtask we focus on, sub-question generation aims to generate natural language sub-questions based on sublogical forms. Similar to the experimental designs in parse correction, we found that, first, considering the templated sub-questions, which is generated using a rule-based method during crowdsourcing, can help further improve generation performance. The second thing is, the original complex question generally leads to better results. So far, all the experiments above are centered around the initial parser we selected at the beginning, but we also would like to study the promise of our framework to correct errors made by other semantic parsers. Therefore, we develop a pipeline which simulates human feedback and apply our framework into other parsers, as shown in the first table. Star here denotes the results after correction. Moreover, we expand the simulation experiment to include multiple attempts of correction to simulate situations in which the model does not repair the parse correctly on the first attempt. As shown in the second table here, parse correction performance can be further improved after a few attempts of correction. Lastly, I would like to briefly talk about the discussion and our future work from two topics. One topic is about the interactive learning via simulation pipeline. So the simulation pipeline provides an efficient means of automatically evaluating different model variants and settings in an interactive scenario without requiring further human efforts. The simulation pipeline can produce more simulated interactions and correction turns in a dialogue when handling new questions. If we incrementally add simulated data produced by the pipeline to the training process of the parse correction module or base parsers, the learning curves could be obtained to explore the relationship between the simulated data volume and the parsing performance. It will allow us to examine the balance of efficiency both in human annotation and model resources, and also the performance gains. Another topic is about human in the loop. We hope to generalize the framework to handle other unlabeled questions for parsing and involve human users. By interacting with the framework, human users can provide feedback to directly correct parse errors without requiring extra annotations and validate the answer in a timely manner. On the top of that, the mispredicted parse recognized by the user can be treated as negative instances to enhance the training process via contrastive learning, which would help further improve the parsing performance. Okay, this wraps up my talk today. This research is partially supported by a collaborative open science research agreement between Facebook and the Ohio State University. Feel free to scan the code below to check our dataset and code. Thanks for watching.